So now we will discuss about the expression for the thermal conductivity. Expression for the thermal conductivity, its definition is amount of heat flowing through the material per unit area, per unit time, per unit temperature gradient. Okay. So now we will take as one of our considered uniform rod. Okay. This is our considered uniform rod, and also this one end is A, another end is B, and also at the end of A temperature is T1. At the end of the temperature, at the end of B is nothing but the temperature is T2 சொல்றோம். ஓகேவா? So here, and in this A end ஓட temperature is T1 is represented by hot temperature, and then this T2 temperature is nothing but cold temperature, cold end or cold end னு சொல்லிடலாம். ஓகேவா? Cold end or hot end we will take next. ஓகேவா? And also here, it's a cross sectional area is nothing but this is the center of cross-sectional area here. So it's represented by C here. And also its mean free path is lambda. Its mean free path is lambda here. The total length of the material is, we will call as the 2 lambda. We will call as the 2 lambda. Okay. So now listen now. So we will take it as one of our considered rod. Listen. Considered rod, one end is A, another end is B. At the end of A is the hot end, so its temperature is T1. Okay. At the end of B is cold end, its temperature is T2, and also its area of cross sectional is C here, and also so here the length of the material is 2 lambda dimension. The length of the material we will call as the 2 lambda. Okay. So now we will write the term of amount of heat conducted. Listen, amount of heat conducted in our considered solid material at the end of A to B. Okay, at the end of A to B. So amount of heat flow வந்து நம்ம என்னன்னு சொல்லுவோம் Q அப்படினு சொல்லுவோம். ஓகேவா? So amount of heat flow. Okay. So Q is directly proportional to. So Q is directly proportional to. So you have to write here A into T1 minus T2 into time period and then divided by 2 lambda. Okay, so here Q is directly proportional to area of the cross section, and then T1 minus T2 is the temperature difference. Okay, A to B of the temperature and T1 minus T2 na the temperature difference. Okay, so T1 minus T2 into that particular time period, and also here they divided inversely proportional to the distance. Understood? Up to this here. Okay, so now we will write the term of the Q is equal to K. K is what here? Thermal conductivity. It's the constant of proportionality. So K into A into T1 minus T2 into T divided by 2 lambda. So 2 lambda. Okay. Up to this here. Any doubt in this step? So this is your equation 1. Okay. So here I already explained about this the definition for the thermal conductivity. So the amount of heat flowing through per unit time, per unit time, per unit what here? Per unit area, no? So here time period we will take as 1 second, and then when the area is equal to 1 meter cube. Okay. So what you write Q is equal to, so here A into A is nothing but 1. So we write 1 minus T2 into time period is also 1 divided by 2 lambda. Okay, va? What ma? Okay. So the next step you have to write here. So what you write here, you have to calculate about K. So K is equal to what here? Q divided by and then T1 minus T2 into 2 lambda. Understood this step? Any doubt in this step? Any doubts? Okay. So in this step update. So this one is the third equation. This is what your third equation. Okay. Third or second? Second equation. Okay. Second equation. So now the number of electrons. So the number of electrons crossing per unit area per unit time. Right here. Number of electrons crossing per unit area per unit time is equal to 1 divided by 6 n into b. Okay, n into b. So this is the third equation. Listen now. So the number of electrons crossing per unit area, just write down and explain you. So the next step is the average kinetic kinetic energy of the electron. Average kinetic energy of electron at hot end. At hot end, A is equal to 3 by 2 kBT. P is 1. So this is the fourth equation. This one is the fourth equation. Okay, listen. This one is the fourth equation. Okay, now listen. Listen. Up to second equation here. Any doubt in this step? Up to second equation here. So now come to the number of crossing electrons. Number of electrons crossing per unit area per unit time period. Listen now. Listen now. So here I take as electrons or the possible direction, moving direction. So when it is moving along x direction. So for example, when the electron, when we apply some temperature, so temperature when we pass பண்ணும்போது electrons is getting some motion, vibrate ஆகுதா, அதோட possible directions என்ன இருக்கும்னா ஒண்ணு along x direction ல move ஆகும், இல்லனா y directions ல move ஆகும், or it is moving in z directions ல move ஆகும், இல்லையா? Okay, otherwise it is moving in negative x direction, negative y direction and negative z direction. So totally how many directions here? 6 directions. So the motion of the electrons would have possibility directions வந்து 6 directions இருக்கு. ஆனா அந்த 6 directionலயே electrons move ஆகுது. Each and every it is moving in any one of the directions தான். So that's the reason நம்ம என்ன போடுறோம் 1 by 6 out of 6 directionல electrons it is moving in any one of the direction. So you write here 1 by 6 into எது move ஆகுது number of electrons into that is speed. அதோட ஸ்பீட மென்ஷன் பண்றது or velocity கூட சொல்லலாம். ஓகேவா? velocity represent பண்ணுவோம். So you have to write 1 by 6 into np அப்படினு போடுறோம். Any doubt in this step? Any doubts ma? Okay. So இப்போ என்ன போட்டுக்கோம் number of electrons crossing per unit area per unit time period is equal to 1 by 6 into np சொல்றோம். Understood? So the next step the average kinetic energy of the electron. Okay. So each and every electron have average kinetic energy. Its formula is 3 by 2 kV. kV போடலாம் or you should write kV. kV is nothing but Boltzmann constant. Okay. So here 3 by 2 kVt. But here we should take as at the end of A. A end of the temperature என்னது? A end of the temperature என்னது? T1. So the average kinetic energy of the electron at the hot end A is equal to 3 by 2 kV T1. The temperature T1 in everything. Understood? This is so now we will write the term of average kinetic energy. If I get the next step average kinetic energy of electron at cold end. At cold end B is equal to 3 by 2 and then kV P2. So this is your fifth equation. Up to this here, any doubts? Okay. So here next one is now the amount of heat flowing through the material at the end of A to B. You will write. Okay. So the average kinetic energy for heat flow ஆகுது. In our consider A to B னா அப்ப kinetic energy இருக்குது. At the same time number of electrons இருக்குது. ஓகேவா? So ரெண்டையும் multiply பண்ணா we will get the term of the amount of heat transfer through the A to B க்கு கிடைச்சுமா? So you write here. Heat transferred from heat energy transferred from A to B across C is equal to number of electrons into average kinetic energy of electrons in a formula. Okay, so like see here the heat energy transferred from A to B across C. Listen here, the heat energy transferred from A to B. Okay, across C is nothing but its number of electron into the average kinetic energy of at the end of A. The average kinetic energy of at the end of A. So what you write here? heat is transferred. ஒரு heat transfer ஆச்சுன்னா நம்ம என்ன சொல்லுவோம் இந்த சில இடத்துல C கொடுத்துருக்காங்க let's say Q அத நம்ம ஃபைனல் Q மென்ஷன் பண்ணிக்கலாம். So here is equal to number of electrons is what here 1 by 6 into n into V into average kinetic energy is what here 3 by 2 into kV T1 kV T1. So here 2 here is cancel. What will you get here? So here 1 divided by 1 divided by 4 into n into V kV T1. So this is the sixth equation. In the same way, we should calculate about the next step. Okay, average kinetic energy, heat energy transferred from B to A. We will calculate about B to A. Okay, B to A को number of electrons into the average kinetic energy of the electrons at the end of B. Okay, so what we write here is equal to number of electrons into average kinetic energy of electron at B to A at B. So what will you get here? 1 divided by 6 n into V square into 3 by 2 kV T2. So here cancel 2, here also cancel 1 divided by 4 n V square into kV into T2. So this one is the seventh equation. This one is the seventh equation. Up to this here, any doubts? Now we should calculate about less than. Oh, sorry. Thank you. Okay. So next step then write the term of the net heat energy transfer. The total net for the difference எடுக்கிறோம். The net heat energy is transferred from at the end of A to B. So subtract பண்ணலாமா? So A to B எடுத்துட்டோம், B to A க்கு போட்டாச்சு. Now we have to subtract these two equations. Okay வா? So right here the net heat energy. எழுதிக்கலாம். Net heat energy transferred from A to B. So what you get here, the net heat energy we call as Q. It's represented by Q. So Q is equal to the net heat energy is represented by Q is equal to we will minus these two equations. 6 subtract equation 6 minus 7 here. What will you get here? 1 divided by 4 n into V kV T1 minus 1 divided by 4 n into V kV into T2. Okay. Here which one is common here? 1 by 4. So Q is equal to 1 by 4 n into V and then kV and then T1 minus T2. So this is the eighth equation. This one is the eighth equation. Now substitute. Listen. Now substitute equation 6 in equation 2. Equation 2 என்னது? Q is equal to equation 2 is which one ma? K is equal to Q divided by T1 minus T2 into 2 lambda. Now substitute equation 8 in equation 2. Substitute equation 8 in equation 2. Substitute and do the answer. So K is equal to Q என்னது நமக்கு 1 divided by 4 into NV KV T1 minus T2. So இங்க என்ன இருக்கு? So divided by என்ன இருக்கு? T1 minus T2 then 2 lambda. Yeah. So here which one is cancelled? T1 minus T2 is cancelled here. So finally next term la enna irukku? Here 2 is cancelled. Here 4 is cancelled. Now what will you get finally? So K is equal to n into V into KB lambda divided by 2. Understood? Up to this here. So here what will here collision time. இப்போதான் அந்த collision time introduce பண்றோம். Collision time is equal to relaxation time. So here the motion of the electrons we will substitute in this lambda value. Okay, so this is the formula. Number T is equal to, so T is the relaxation time, is equal to the collision time. Listen, T is equal to relaxation time, Tc is the collision time. So the collision time oda formula enna Tc is equal to lambda by v. Okay va, Tc is equal to lambda by v, but here T is equal to Tc, no, T is equal to what is that, lambda by v. Lambda is equal to what is that, lambda is equal to v into T here. Okay, so this one is the equation 7 or 8th equation. This one is the 9th equation. Okay, substitute equation 9 in equation 8. Substitute equation 9 in equation 8. Equation 9 in equation 8. So what you get here? K is equal to n into T kT, and then V into T divided by 2. So finally K is equal to n T square kT into T divided by 2. So this is the equation for the expression for the thermal conductivity. Is there any doubt, ma? Doubts irukka? What, ma? 3 by 2 it's the average kinetic energy formula. 3 by 2 kT nale vandu it's average kinetic energy. What, ma? It's a constant average kinetic energy. Okay, ma? So T1 ன்றது ஏன் ரெப்ரசன்ட் பண்றோம்னா at the end of A க்கு ரெப்ரசன்ட் பண்றதுனால we will put it T1 அப்படினு சொல்றோம். Understood?